Okay, so in the previous class, we have discussed how the electrons get filled in each shell starting from the first shell. And in the first shell, as we have discussed, there is a space. The 2 electrons get filled in the first shell, then 8 electrons get filled in the second shell, then 8 electrons gets filled in the third shell, and then 2 electrons get filled in the fourth shell. Now, there is a task for you guys. You have to write the electronic configuration. Okay. So let's start with the hydrogen. So what this number is telling us about the hydrogen? Yeah. So if you recall from the previous class, we have discussed that in the subscript like this, it's an atomic number, which means number of protons. And if there are number of protons are 1 and there is no charge on it, it means that the number of electrons are also 1. So then it means its electronic configuration for hydrogen is going to be 1 only. For helium, it is going to be 2. For lithium,
2 and 1.
Not there are 3 electrons, but in the first shell,
2.
2 electrons, and then in the second shell, 1 electron. Then 2, 2. Okay. Now, in the similar manner, write the electronic configuration starting from the boron till calcium. Okay.
Okay.
So complete these as quickly as possible. This one I have done. Okay. What about you, Khatija?
Yes, about to done. The last one is left only.
Okay. Showing you. Yes, Khatija, are you done?
Yes.
Okay, so let's have a look. I'm writing over here and you guys can check yours. So for boron, it is going to be 2,3. For carbon, 2,4. For nitrogen, 2,5. For oxygen, 2,6. For fluorine, 2,7. For neon, 2,8. For sodium, it is going to be 2,8,1, right? Then for magnesium, it is 2,8,2. For aluminium, 2,8,3. For silicon, 2,8,4. Then phosphorus, 2,8,5. Then silicon, 2,8,6. Then chlorine, 2,8,7. Then argon, 2,8,8. And then we have a potassium, 2,8,8,1. And the last one is calcium, 2,8,8,2. So examiner usually asks the electronic configuration in the exam from these 20 elements, and the maximum of for 20 electrons in an atom, not greater than that. Okay.
Yes.
Whenever the last shell is called outermost shell, or we call it valence shell, okay, then if we look in the periodic table, okay, just wait. If you look in the periodic table and you have written the electronic configuration, let me show you something. If you look at lithium, how many electrons are there in the valence shell of lithium? Valence shell. Valence shell means the outer one. How many electrons are there in the valence shell of sodium?
1.
How many electrons are there in the valence shell of potassium? 1. Right? So in the outermost shell of lithium, sodium and potassium, the number of electrons are 1. So see, if you look, here we have a lithium, here we have a sodium, here we have a potassium, and they are all in the group 1. So if you look at the beryllium, how many electrons in its valence shell? 2. How many electrons are there in magnesium in its valence shell? In calcium's valence shell? 2. So see, its group number 2. Are you getting this? So it means that it will be very helpful if you remember this thing, that the group number is going to tell me how many electrons are there in the outermost shell of that atom. For example, if you want to further confirm, let's have a look at the valence shell of aluminium. Check in your notebook where you have written. How many electrons are there in aluminium? 3. So see, its group number is. Now look at the electrons in the outermost shell of fluorine.
6.
No, not 6. 7. And see, its group number is 7. Is this understandable? Okay. Now another thing. If you see in the periodic table, these horizontal lines are called periods. So if you look in the periodic table, in the first period, how many elements are there?
1.
2, right? Right, Khatija?
Yes, yes.
In the second shell, how many elements are there?
8.
8. So now see, if you look at the electronic configuration of lithium again, how many shells are there in lithium?
2.
Shells.
2.
In the first shell you filled yes two electrons, and in the second shell you filled 1 electron. Okay, now look at the shells in the nitrogen.
2.
2. Let's suppose check the shells in chlorine. 3.
3.
Check the shells for calcium.
4.
So see, calcium is in period 4. It have 4
Yes.
shells. Chlorine is in period 3. It has 3 shells. You have seen for lithium, it's in period 2 and it have 2 shells. So the period number, the horizontal row in which row it is placed will help us to identify how many electron shells it has. Is this understandable?
Yes.
Okay. So now note this down. आपको देते हैं या नहीं पेपर में बात इसलिए
Sir? In second point, it is written that with the exception of helium. So what does that mean?
Yes, I'm going to tell you the exception of what exception helium has.
Okay.
Okay. Last class alone bomb करते थे तो आपने पिक्चर क्लियर हो की बात है Done? Yes, Khatija?
Yes, done.
Okay. So, as we have seen that group number tells me that how many electrons are there in and what
Outermost.
else? Outermost shell? Valence shell.
Valence.
Okay. And as we have mentioned in the point with the exception of helium, right? So what is the exception of helium? It's in group 8. So if the elements are in group 8, it means they are going to have 8 electrons in their outermost shell, right? So if you see helium's electronic configuration, you have written how many electrons are there? 2 only. And why is that? because how many shells helium have? Helium have only one shell, that is the first shell. And in first shell, there are only 2 electrons which can be accommodated. So that's why it is the exception that helium group number does not correspond to the number of electrons in its valence shell. Otherwise, if we talk about neon, argon, krypton, xenon, radon, everyone, all these are in group 8. It means their outermost shell have 8 electrons. If we look at these elements, nitrogen, phosphorus, arsenic, antimony, bismuth, and all these, as their group number is 5, which means they all have they all have a 5 electrons in their outermost shell. Is this clear?
Yes.
Okay. Okay. So that's what the exception is. And as we talk about group 8, we consider the elements that are in group 8 have a full outer shell. It means that in their outer shell, the maximum electrons are actually filled. Okay. How many points you have noted down? 2. So you are on period number is equal to. Now, electronic structure. Okay, so that is the drawing, and that drawing we call it electronic structure, in which we draw the electrons in each shell on the basis of their electronic configuration. Okay. Done. Yes, Khatija?
Yes, sir.
Okay. So when we are going to draw these electrons, in the first shell we know how many electrons are there, only 2. So that 2 electrons can be drawn as paired or unpaired. Both are considered to be correct, but in actual, the most appropriate way is drawing those 2 electrons as paired. Okay, so but both can be considered as correct. But when we come to the next shells, where we have to fill the 8 electrons, so if that shall have either 4 electrons or less than 4 electrons, then we draw them as unpaired, and then those 4 electrons will be paired up with the other electron if the electrons are more than 8. Oh, sorry, are more than 4. For example, let's have a look for phosphorus over here. So the electronic configuration of phosphorus is, yes, 285. There are 15 electrons. So the
Yes.
electronic configuration is going to be 285. right? Okay, so that 285 is telling me that 2 electrons are in the first shell, then 8 electrons are in the second shell, and then 5 electrons in the third shell. So if I have to draw the electronic the electronic structure for phosphorus, I will do that way. I got to know from the electronic configuration that there are 3 shells. So I'll write a P in the center and then make 3 circles which are representing the 3 shells. Is this clear? Now,
Yes.
I will do next, in the first shell, how many electrons are there?
2.
2. So I'm going to make the 2 electrons as pair, as we have discussed that you can draw it as a pair or unpaired, both are correct. Okay. Then in the second shell, 8 electrons. So these 8 electrons are going to be drawn like this. Make a first electron, then draw second electron, then third electron, and then fourth one. So see, I draw all the 4 electrons unpaired initially. Now if I have to fill more electrons in the same shell, now I'm going to make them, the next coming electrons are going to be paired with these electrons which are there. So it means that the 5th electron is going to be paired with one of the electron that is already present. In the similar way, 6th electron is going to be paired, 7th electron is going to be paired, and the 8th electron is going to be paired. Is this clear? Now, in the third shell, how many electrons are there? 5. So, first electron, second electron, third electron, fourth electron. So I put the 4 electrons as unpaired, and I have to put the 5th electron. So I can pair it up with anyone, it doesn't matter. But the 5th electron is going to be paired. Is this clear? So that's how we draw the electronic structure. Okay. Now you have seen how to draw it. Now, it's your task to draw the electronic structure for these 4 elements: aluminum, silicon, sulfur, and chlorine. So you can share if you are done.
Okay, sir. I'm sharing.
जी कंप्लीट कर लिया ओके जी ये देख लीजिए ठीक है सही है आपको भी क्लियर है दिस Khatija is it clear to you as well
Yes.
okay okay so we are observing that all of these four atoms have how many shells three shells so it means when we try to find them in the periodic table we are going to find locate them in period 3 and if you look at the electrons present in their valence shell, so aluminum got 3 electrons in its outermost shell or the valence shell, which means that it is going to be present in group 3. Silicon have 4 electrons in its valence shell, so it will be present in group 4. Sulfur have 6 electrons, so it is in group 6, and chlorine have 7 electrons, so it have group 7, right? And
Yes.
do remember that periods are the vertical rows, or sorry, horizontal rows, and the groups are the vertical columns. Then, yes,
Yes.
Khatija?
Yes.
Now, the electronic configuration of ions. We have done the electronic configuration of atoms for today. Now, ions are what? Ions are charged particles. If the atom or a group of atom have a charge, then we call it ion. For example, see here, aluminium have a 3 positive charge. If I write aluminium like this, then it's an atom. Okay, but if we put a charge over here, then it becomes ion. In the same way, this sodium is not an atom, but an ion because it have a positive charge over there. In the similar manner, this chlorine and oxygen are actually not atoms, but ions. Is this clear? Okay. So the ones with
Yes.
a positive charge are called cations, and the ones with a negative charge are called anions. So that is the classification of ions into cations and anions. One more thing. If it's an aluminium ion, it have a 3 positive charge. So what I'm going to call it? I'm going to call this one let me write over here its name. Its name is going to be aluminium ion. Then what will be the name of the next ion?
Sodium ion.
Sodium ion. Then what will be the name of next ion? And the next one?
Oxygen ion.
Chlorine ion and?
Oxygen ion.
Okay. So this thing is different. For negative ions, we cannot name them as a chlorine ion or oxygen ion. Okay. So what is the difference when the atom becomes a negative ion? Then the suffix of the name is changed by IDE. Now we cannot say it a chlorine ion. We will call it
Chloride
chloride
ion.
ion. Now what we are going to call next one?
Oxide ion.
Oxide ion. See, if you recall the name of the compound like carbon dioxide. So why we are saying instead of oxygen, why we are saying oxide? It means that their oxygen is in the form of its ion. Is this understandable?
Yes.
So you have to uh, keep this thing in mind. Whenever there is a positive ion, we just write the ion in the suffix of the name of that element. Like Al is aluminium, but when it have a 3 positive charge, I will call it aluminium ion. But when an atom becomes a negatively charged ion, then the suffix is replaced by id. For example, if it's Cl, then I call it chlorine. But if it have a negative charge, then I will going to call it chloride ion. Is this understandable?
Yes.
Okay. So why they got a positive charge, or why the positive, what are actually the cations or the positive ions? Okay, what is the charge of proton?
Zero.
No, check in your notebooks. We did in the last class. Okay, you two were late. Yes, Manahil. The charge of proton, the relative charge of proton is positive 1, and the relative charge of electron is negative 1. Okay, so if the ion is positive charge, it means that it have a lesser electrons than the protons it has. Because if the protons and electrons are equal, then there will be no charge. So if it means that it lost its electron, and the number of electrons that are lesser is going to be figured out by the value of the charge. Is this understandable?
Yes.
Yes, Zainab. Done. Okay. So see, this 13 is what?
Proton number.
Proton number. And it means there are how many protons in aluminium?
13.
13. It's 13, right? And what is the charge over here?
3
3
plus.
positive. It indicates that the electrons are going to be, there are 3 electrons which are less than this number. So the protons are going to be 13 and the electrons are going to be
10.
10. The protons are going to be 20 and from this value the electrons are going to be 18. The protons are going to be 3 and the electrons are going to be 2. Is this understandable?
Yes.
And that's how then we can write the electronic configuration. We got that there are 10 electrons now. So we'll write the electronic configuration for 10 electrons, which is going to be 2,8, here 2,8,8, and here 2. One important thing, when we draw the electronic structure for ions, we always close the electronic structure of ions in the square brackets and then put the charge over here like this. For atoms, we do not do this.
Sir, can you please scroll down?
Here. Okay. So remember, for the electronic structure of ions, we always go enclose them in the square brackets and put the charge on the top right of the square bracket. Is this clear?
Yes.
Yes, done. Yes, Khadija.
Done.
So if you compare it, you have drawn the electronic structure of aluminium earlier. You can see that here there is a third shell as well. If you look in your notebooks, you will find that there is a third shell as well, and in that third shell there are 3 electrons. So when aluminium become iron, it lost the electron from its outermost shell. So as a result, in aluminium ion, out of these 3, 2 shells are left.
Yes.
And it becomes charged now. Okay, so let's talk about anions. So when we talk about anions, they are negative charge, and negative is the charge of electron. So it means these are the one which gain electron in their outermost shell. And as a result, their outermost shell becomes completely filled. If it's the first shell, it have a 2 electrons after gaining the electron. If it is any other shell except the first shell, then after gaining these electron, its outermost shell have 8 electrons in it. And the value of the charge again tells us that how many electrons are gained. Is this clear?
Yes.
Okay. Yes, Zainab. जी यहाँ तक करिए. Yes, Khatija.
Yes, I done.
Okay, so in this nitride ion, if I ask you how many protons are there?
7.
7. And how many electrons are there? 10. Here, how many protons are there? And how many
16.
electrons are there? 18.
18.
And here, how many electrons are there? 18.
18.
And are 17. Is this clear?
Yes.
Okay. So from the value of the negative charge, we got to know how many more electrons it had. Then, okay. Now, if it's not a nitride ion, then how many electrons were there in the outermost shell? No. Now it's a nitride ion now, right? And when it's a nitride ion, there are 8 electrons in its valence shell. If it's an atom instead of this ion, then how many electrons here it has?
5.
5. Because see, it gains 3 electrons, right? So that's why it is going to be have 5 electrons. In the similar way, here there was how many electrons there was before it becomes ion? Why? How many electrons it is gaining? Yes, Jana? 2. So it means 6 electrons over there. Is this clear? Now, in this chloride ion, it was 7, and when it gained 1 electron, there is 8 now, and it becomes chloride ion. Okay, so when we draw the electronic structure of these, we make a little difference as compared with the previous one. In the previous one, the electrons we draw, we represent those electrons with the dot. And in the previous case, uh, the case of a cation, the electrons were lost, right? So those electrons are actually gained by these atoms. That's why they are become negative ion. So what do we do? The electrons which they initially had, we are going to draw them with the cross, and the electrons which they gain, we represent them with the dot. So from the electronic structure, we can identify the electrons which are actually gained by this. Is this understandable? So see,
Yes.
as we have decided for this one, that it has, if you see over here, that it have 5 electrons initially. So see, I have drawn the 5 electrons with the cross in the outermost shell, and then the 3 electrons with the dots. It is 14. Then, okay. So then we got one electron with the dot in fluoride because it means one electron. Sulfide, it means 2 electrons, so we put that 2 electrons by dots. Is this clear? Okay. So we will keep our today's class till here. Okay. Khatija, are you done?
Yes, sir.
Zaman? Okay, so we'll continue from here in our next class. Okay. Take care, everyone. Allah Hafiz.
Allah Hafiz.